Dilation. Okay, now this is the last transformation we're going to do. We've done translations, reflections, rotations, and dilation is our last one. Let's start with just a definition of dilation. So a dilation is when we enlarge or reduce a figure. So what we're going to do is we're going to take a figure and we're either going to blow it up or shrink it down. And one of the things that we're going to kind of institute here too is the idea of similarity. So when we do these things, our shapes are not going to be congruent anymore, but they are going to be similar to each other. So this is something that we're kind of talk about in our next unit, is how these shapes end up being similar to each other. Now, how we enlarge or reduce these things, we do this with a thing that we call its scale factor. And scale factor is going to be used the variable k. So what we're going to do is we're going to use k, and that's going to determine how big something gets or how small something gets. And that k factor that we use, we're going to be multiplying all of our ordered pairs by. So I'll show you that in just a second. But I want to give you an example of what these things will look like. So here's our pre-image. Let me get my pre-image. So if this is my pre-image, right here I've got just a simple rectangle A, B, C, D. Right now, if we were going to reduce that, here's a reduction of it. So we've taken and we've reduced this down. Now, if I look at this, I cut it so I know. What happened was I took this and now I have a fourth of it. So in this essence, k, the scale factor, was 1/4. So every one of these ordered pairs, each individual x, each individual y, I multiplied by a fourth, and I got a shape that was 1/4 the size. All right, let's look at another example. This one. Let me move this one up and over here. So now I have my pre-image and my image here. Now it's gotten a lot bigger. So what happened here, because I made it, the k factor for this one is 4. So this shape is 4 times larger than the original shape. Okay, so what we're going to be doing is we're going to enlarge or reduce figures using this k factor to give us those points. Let's try one of these problems. Okay, let's try a dilation. We got a figure that we're going to dilate, and we can just check to see what we've got here. I've got this shape. It's over here. It looks like it's a right-angled trapezoid. And I've graphed that shape. That's our pre-image. And then what this says is we're going to increase the size by a scale factor or k factor of 3. So we're going to make that bigger by a factor of 3. Now, seeing how this works will be a little bit easier. So here's pre-image, then we'll put the image onto it. The image should be larger than what we're getting. So here's how we're going to apply that 3. So that 3 is the number that we're going to multiply each of the x's by and each of the y by. That's why I've written here. So it says k times x and k times y. So when I write this in, this is going to say -1 times 3 and 1 times 3. 1 times 3 and 1 times 3. 2 times 3, -1 times 3. And then -1 times 3 and -1 times 3. Then we just do the math. So our new order pair for f here, this is f prime. 3 times -1 is -3. 1 times 3 is 3. 3 times 1 is 3. 3 times 1 is 3. That was g prime. 2 times 3 is 6. -1 times 3 is -3. That is h prime. -1 times 3 is -3. -1 times 3 is -3. And that is I prime. Okay, now we go to the graph. So f prime is at -3, 3. 1, 2, 3, 1, 2, 3. There's f prime. 3, 3 is G, so 1, 2, 3, 1, 2, 3, there's G prime. H prime is 6, negative 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. H prime. I prime, negative 3. 1, 2, 3. Negative 3. 1, 2, 3. And there's I prime. Now I'm going to need a straight edge. It's going to need to be a longer straight edge than my normal straight edge. So let me go get my yardstick. I'm walking, I'm walking, I'm walking, I'm returning. I'm returning, I'm returning, I'm returning, I'm returning. And I got it. Okay, so straight edge here, just so you don't give your math teacher a heart attack. There's one line. Get this on there. 2 lines. From the H prime to the I prime. 3 lines. I got one more to do here. Just trying not to smudge everything. And we'll put that up there to there. Yeah. So what we know is our image here, and then our pre-image is here, then our image is here, and this blue one is 3 times larger than the pre-image, right? So we took each x, multiplied it by the k-factor, took each y, multiplied it by the k-factor, and then graphed the new order pairs. Let's try another one. Okay, different shape now. We've only got 3 vertices to work with, and we're going to graph that. So here's our pre-image. It's already graphed for us. And then looking at the k-factor is 1/2. So 1/2 is less than 1, greater than 0, which means we should be getting a smaller figure at the finish. So k-factor greater than 1, larger image. K-factor smaller than 1, we're reducing, smaller image. So in this one, with a half, what we're going to do is we're going to take a half of each x and a half of each y to get our new ordered pairs. So here I've got 3, 8. I've organized this in a table with the originals. Here's our pre-image. Then we'll be going to our image here with our primes. So 3, 8, so that's 1/2 times 3 and 1/2 times 8. This one is 1/2 of 10 and 1/2 of 6. This one is 1/2 of 8 and 1/2 of 2. Now we just implement the math. So just some simple multiplication. Half of 3, let's go with 1.5. Half of 8 is 4. Half of 10 is 5. Half of 6 is 3. Half of 8 is 4. Half of 2 is 1. All right, so now we've got the ordered pairs here. We've got our primes for our reduction here that we've done on this image. So let's graph it. So I've got 1.54. So here's 1, and then halfway would be 0.5, and then 4. 1, 2, 3, 4. Here is J prime. K prime, 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. There's K prime. Then L prime, 1, 2, 3, 4, up 1, and there's L prime. Now, because it's a reduction, I can get a slightly smaller ruler than my yardstick. Let me get my handy dandy ruler. And please use a ruler. I mean, don't give your teacher a heart attack. There's 1 line, trying not to smudge. 2 lines, trying not to smudge. 3 lines. And there we go. So we took our pre-image and reduced it by a half, and now we're here. So that always is taking that k-factor, multiplying it by all our x-coordinates, then multiplying it by all our y-coordinates, and getting our new ordered pairs. Let's take a look at what a word problem would look like for one of these problems. Word problems for dilations can be tricky if you don't necessarily set it up with a picture. For me, always a simple drawing will make a big difference. So let's look at the problem that we have here. Jesus has a 4 by 6 inch photo of his abuela. Oh, that's so sweet. He loves his abuela. Okay. He wants to make a poster that's 16 inches by 24 inches for her birthday. So they're going to have a big party, and they want to have a nice large picture for that. What scale factor should he use to enlarge that photo. So just a very simple drawing can help us see what we're doing here. So he's got a photo that's 4 by 6. This won't be to scale, but I'm just going to make this bigger, right? So we're going to 16 by 24. That's certainly an enlargement. So I'm just going to, not to scale, but just going to draw this out here to say 16 by 24. All right, so these are similar images, right? Because they retain the ratio in respect to those legs. And let's see, how we're going to get from this to this. So we're just checking for what is the scale factor? What will K be in this situation? So how does the 4 become a 16? Remember what we're using. We're using multiplication here. So 4 times what would be 16? Well, 4 times 4 is 16. Let's check to see if that's the same thing here for 6. 6 times 4 is 24. So we're going to enlarge it by a factor of 4. There's not a lot to those problems, but it's just a matter of saying to yourself, okay, this simple thing has got to become this simple thing. And let's just look at the relationships here. How does the 4 relate to the 16? Let me find a color here. Let's get a color. How does the 4 relate to the 16? And then on those corresponding sides, how does the 6 relate to the 24? Okay, if you have any questions, of course you can ask me. Otherwise, good luck.